Hello learners. In class 9th, we have learned that matter around us is present in form of elements, compounds and mixtures. And the elements contain atoms of only one type. Maybe one day, one amongst you will discover a new element. So ignite the scientist in you. Now coming back to these elements. Do all these elements have different properties? Ponder and explore. Do you know, out of these 118 elements, only 94 are naturally occurring? As different elements were being discovered, scientists gathered more and more information about the properties of these elements. They started looking for some pattern in their properties, on the basis of which they could study such a large number of elements with ease. You must be wondering how they made order out of chaos. So here is memory down the lane, a journey into early attempts at classification of elements. What do you observe in the picture on screen? Imagine you and your friends have found pieces of an old map to reach a treasure. All the pieces are jumbled up. Now, would it be easy or chaotic to find the way to the treasure? Something similar chaos was there in chemistry as elements were known, but there was no clue as to how to classify and study about them. Have you learned to classify various things or living beings in your earlier classes? Yes, you have. And was there any basis of classification? Of course you know. They were classified on the basis of their properties. For example, in a shop, soaps are kept together at one place, while biscuits are kept together elsewhere. And even among soaps, bathing soaps are stacked separately from washing soaps. And what about medical store? How do you think shopkeeper is able to fetch the particular medicine you have asked for so quickly? Similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of chaos. The earliest attempt to classify the elements resulted in grouping the then known elements as metals and non-metals. But there were too many metals and too many non-metals. Later, further classifications were tried out as our knowledge of elements and their properties increased. But keep in mind that all the elements were not discovered that time. Scientists were working with elements which were discovered at that time. Before we start, let us go through a journey about history of periodic table. Come on, hop in on my yellow bus and we will go into time travel journey. Our bus will halt at 4 stations. Station number 1, when you will reach in 1817 Dauburnier's Triads, and from then we will take a road trip to station number 2, when you will reach 1866 Newland's Law of Octaves. And well, from there we are going to take a road trip down to station number 3 in 1869. Station's name is Mendeleev's periodic table, and our last halt will be at station number 4, 1913, and the name of the station is Modern Periodic Table. So, are you ready for the trip? Tighten your seat belts and hold on to the seat handle, and I am rolling my bus. Here comes our first station. Slowly alight from the bus. Can you spot Johann Wolfgang Dauburnier? There he is. He was born in 1780. Shh, children, don't disturb him. Can you guess his age? You are in 1817. So he must be 37 years old. Look how young he looks. Children, make it your habit to know more about the scientists you come across. find out about his childhood, where did he study, what were his hobbies, go ask him. Dubernier made his first observations on platinum as a catalyst. Find out more about his discoveries. I hope you all are collecting sufficient data to be included in your portfolio. Can anyone draw his sketch without disturbing him? Now come here and listen to me. I am your guide for the day. In the year 1817, Johann Wolfgang Dubernier, a German chemist, tried to arrange the elements with similar properties into groups. What does triads mean? Yes, group of 3. Look at one of the Dubernier's triads. Can you see it on the screen? He identified 3 elements that have similar properties each. So he called these groups triads. Lithium, sodium and potassium are metals. They react with water to form alkalis and hydrogen gas. They all have valency of 1. He showed that when the 3 elements in a triad were written in order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. If we take an example, let us take average of atomic mass of lithium and potassium, which is around 6.9 and 39. And what is the average of the atomic masses of lithium and potassium? Well, it will be 46 divided by 2 and which comes out to be 23. How does this compare with the atomic mass of sodium? This is the mass of the middle element sodium. So you see that elements in the triad have similar chemical properties. On the screen are some groups of 3 elements. These elements are arranged downwards in order of increasing atomic masses. In group A, we have nitrogen, phosphorus, arsenic. In group B, we have calcium, strontium and barium. And in group 3, we have chlorine, bromine and iodine. Can you find out which of these groups form Dubernier's triads? Do it with me. Find out the average of first and the last element. Well, I have finished doing it. Have you? What did you find? I am sure you also have found out that group B and C form Dubernier's triad. Well, Dubernier could identify only 3 triads from the elements known at that time. Hence, this system of classification into triads was not found to be very useful. The attempts of Dubernier encouraged other chemists to correlate the properties of the elements with their atomic masses. So children, hop on into my yellow bus again and tighten your seat belts. And now, let us move ahead to our next station, station number 2. Now, you all have landed in 1866. Get down from the bus and let me park my bus under the shade of a tree. Well, that's why we need to conserve our environment. Everyone looks for shade, isn't it? You all move out and search for John Newland till I park my bus here. Do you know this English scientist? He's a music lover. Now gather here as I tell you more about him. He arranged the then known elements in the order of increasing atomic masses. This law of octaves is inspired from music. Are you familiar with musical notes? In the Indian system of music, there are 7 musical notes in a scale. In your music class in school, I am sure you have seen or played harmonium. Well, if not, then you must. Look here on the keyboard. Sa, re, ga, ma, pa, dha, ni, sa, sa, ni, dha, pa, ma, Now, if you focus at sa, the first note is sa. Now, eighth note again is sa. So, every eighth note, that is sa over here, is repetition of the first note, and it is the first note of the next scale. This is called periodicity, means there is repeating pattern occurring at regular interval. Now, can you give me some examples of periodicity? He started with the element having the lowest atomic mass, hydrogen, and ended at thorium, which was the 56th element. Thorium is not shown here on the screen in the table, as this is only a part of the original table of Newlands. Here, each row has 7 elements. He found that every first and eighth element had same chemical properties, and so do second and ninth. He compared this to the octaves found in music. Therefore, he called it law of octaves. It is known as Newlands law of octaves. Well, let us take an example. Let us consider the second element, lithium. Now, if we start counting from lithium, 1, 2, 3, 4, 5, 6, 7 and 8. Yes, sodium is the 8th element after lithium. In Newlands octave, the properties of lithium and sodium were found to be the same. Now, if we count again from sodium, which is the 8th element? You can count and see, it is potassium. So, properties of sodium and potassium were found to be similar. Similarly, if we take third element, beryllium, and start counting from beryllium, the 8th element is, yes, you have guessed it. You can see it also on the screen, it is magnesium. So, properties of beryllium and magnesium resemble each other. All was going well till certain limitations to this law were found. You know what was the first limitation? It was found that the law of octaves was applicable only up to calcium, as after calcium every 8th element did not possess properties similar to that of the first. Second issue was, it was assumed by Newland that only 56 elements existed in nature and no more elements would be discovered in the future. But later on, several new elements were discovered whose properties did not fit into the law of octaves. Let us take a closer look at Newland's table. In order to fit in elements into his table, Newlands adjusted 2 elements in the same slot, but also put some unlike elements together. Can you find examples of these from the table shown on the screen? Note that cobalt and nickel, they are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Now, look here again, iron, which resembles cobalt and nickel in properties, have been placed far away from these elements. More so, with the discovery of noble gases, the law of octaves became irrelevant. Thus, Newland's law of octaves worked very well with lighter elements only. Now, it is your assessment time. Ask your friends these questions. You may either do peer-to-peer assessment or do self-assessment. Here are your questions. Did Daubernier's triad also exist in the columns of Newland's octave? Have a discussion with your friends, compare and find out. Now, the second assignment which I have given you is, make WhatsApp groups with 3-4 friends and find out from internet or library about other attempts to classify elements in this era. Well, so children, what have you learnt till now? We learnt why we have periodic table in science. That is to classify or group the elements. Remember, not compound and mixtures. If you look carefully in periodic table, do you find compounds such as water, sodium chloride in the table? No, you don't. You have also learned to classify elements on the basis of similarities in their properties. And you have learned to take initiatives to know more about scientific discoveries. You can appreciate the contribution of scientists made over the time, like Dobonier, who grouped the elements into triads, and Newlands, who gave the law of octaves. You also can appreciate how concepts of science evolve with time, giving importance to its historical perspective. Come on, hop on into my bus. Well, children, how was your meeting with Newland? Well, from 1866 station number 2, it's time to move on to the next time zone. That is station number 3, 1869, Mendeleev's periodic table. So till we meet again, happy learning.